So hi everyone. My name is Festus, and I'm going to be giving a talk titled "Building Kubernetes: a Lite version from scratch in Go." So before I move on, I just want to appreciate the organizers of SysConf conference, right, for organizing something like so impactful and innovative. I've been a long follower of SysConf, from like database internals, right, and the whole series that they've had, and I think it's quite like innovative and really nice to like have people organize like really highly technical talks like syscoms, and I'm happy to be speaking at syscoms today. So let's just get straight into it. So we have 30 minutes for this talk, right? And I'm just gonna try my best to see how what we can like actually just do like within this 30 minutes. But yeah, let's just buckle up our seatbelts and let's get ready to roll. So who am I? My name is Festus. I'm a 10x engineer. I'm currently an AI engineer at Plexi, YCX25. So what we do at Plexi is we're building and scaling infrastructure for autonomous ML engineering agents. So in short phrase, what we're just really doing is when you text, like you can prompt the models and they actually get help you to build a machine learning model, right, from end to end, like feature engineering down to the end. I previously co-founded and built fintech infrastructure that handle millions of transactions at Bridgecard. And I've worked previously at companies providing financial services in Africa. So one thing that's interesting is I've done side quests quite across the stack. I've worked in machine learning. I've written Flutter with mobile app development and like written quite like some frameworks in backend development. Currently, I'm doing the main quest on AI infrastructure. Yeah. So outside work, a decent long distance runner. Yeah. So I'm Festus on Nike Run. Would be glad to connect with anybody on that's all Nike Run, and yeah, we could motivate each other. So yeah, that's just pretty much that. So yeah, before we move on, just wanted to do like a quick poll. So let's see if we could just do this for like 1 2 minutes. So how well does anybody actually know Kubernetes? Yeah. So this is I have like a QR code, and then you can just like scan it and just yeah, let's just actually pop it up. So yeah, just give like 1 2 minutes for like this, right? So let's just see the responses that come up, and I mean we could also like come back to it. So that just I'm just gonna give like some 30 seconds down to like this, and let's see. Okay, we can see okay, if you have some have used this in production, and someone is asking what's a cube. Okay, so we see I've played with it a bit. Okay, seems we have like a kind of like a balanced audience here. So we just want to see. Okay, I've played with it a bit. Seems like there's a lot of people. Okay, using in production. Okay, uh, we have about 10 seconds. Like, just want to just see. Uh, all right, so that's really good. So we have a lot of people that have actually used it in production. I mean, compared to like played with it a bit and what's a cube. So maybe we could like go through the content faster. But yeah, I'll still try to like explain for like the general audience. So why on earth did I decide to do this? I mean, I think that's like the question many people asked when I published this article. So just briefly, this talk is based on this article on my Medium, Building Kubernetes Lite version from scratch, and also this project on GitHub, right? Everything is also in the link on Twitter that announced the talk. So the question is, why on earth did I actually decide to do this? Like, why would I decide to do this? So there are two reasons to the fact. First one is I come from a school of thought where I believe that building things from scratch actually helps you to understand how things work internally. And then by understanding how things work internally, you're able to apply those problems, right, to other domains, right? So, I mean, there's like a myriad of like places in tech where we see that happen. For example, like the attention is all you need paper that was released by Google, right? And this was like the base paper that was used to like scale LLM. So it's really just like understanding those things on a low level, and then you begin to see how these algorithms were implemented, and it gives you ideas to actually like do things. And generally, I think that you can't really say you understand something unless you've built it from scratch. Yeah. Second reason would just be I think at the point where I wrote the article, I was looking to like how we could better Kubernetes to handle AI workloads. There's actually like a whole lot of work on that in terms of like extending the Kubernetes API, especially like the inference API to be able to like handle AI workloads. And then for me, I wanted to understand, okay, how does Kubernetes actually work internally so that we could actually work on like extending this, right, to support AI workloads, because it was traditionally built for like the web services and not necessarily like the AI workloads or the agentic workloads that we have now. So that's just like a summary of why I decided to do it. So quick table of content. We just have all of this crash course. I don't really want to go through all of this because of our time. But yeah, this just gives you like a high level overview of what we would actually just be going. All right, so a crash course on Kubernetes. So in the next 1-2 minutes, I'm going to attempt to do a crash course on Kubernetes. I mean, let's just see what we can do. So Kubernetes, it's actually sounds scary sometimes when you hear it, right? And it's actually abbreviated as K8S, and that's because like there's 8 characters between the K and the S, like just in case everybody didn't know why Kubernetes is usually called K8. That's actually like the reason why it's actually called K8. All right, so Kubernetes is an open source platform released by Google in 2014 that automates deploying, scaling, and managing of containers. So what is it actually solving? So think of the fact that Docker kind of helped us to be able to like package our applications. So for example, let's say you have like a blog app. Docker helped us to like easily package this application into the container. And then now we can now run this container on a machine or run it on a node. And what Kubernetes aims to solve is, now that we have this container, how do we do interesting things? Like how do we scale this across different nodes, right? How do we scale this across different machine types? For example, especially like more prevalent in the AI age, right? Some GPU types are are able to run your application better because you've tuned the application logic for that machine, right? And then Kubernetes helps us to like solve all of these challenges. Like how can we scale this pod? So let's say a lot of people are actually visiting my blog post. How do I go from a single instance and how do I scale to like a lot of instances? That's what it actually solves. So there's this Kubernetes made easy diagram by at Niraj Kum. So I just like borrowed this because I felt like it could really just help us to do the crash course. So what happens is that your container or multiple of your containers get runs on a pod, right, in Kubernetes. So think of pod just like how we say like Atom is like that single indivisible like unit. The pod is like that single unit in Kubernetes, and it's the smallest available unit that can run one or more containers, right? And let's just say one container just for now, because like the concept of more containers is kind of like, but let's just say it can run one container, your blog app. So what that happens is that Kubernetes is kind of like structured in this process. Let's take to the left, where you have your control plane and you have your data plane. So think of your control plane as like the brain of Kubernetes, right? So what the control plane has is the API server, etcd, the scheduler, controller manager. Don't worry, we're going to be going into like all of this. And then the data plane is actually the machine that actually runs your pod. So most times in Kubernetes, you hear things where you say, oh, I have a single node cluster or a multi-node cluster, right? It's just basically like how many nodes are available for your pods to actually run. And a cluster is just a group of pods, right? A group of nodes rather in a managed single system. API server, think of it as like a front door to your cluster operations. We're going to like talk deep into like this. So I just want to do in a high level. Kubelet is an agent that runs on each node. So the kubelet is actually what is actually responsible for like taking that pod and then taking the pod through the life cycle of like pulling the image and then like starting the pod up. Then the scheduler actually decides which node runs each pod. So like I said, in the AI phase, right, you might say, okay, I want a certain pod to run on a certain node and I want to just run on this node, right? These are kind of like the logic that the scheduler has to like see based on your resource to actually deploy that. And then etcd is a distributed key value store for all of our cluster here. So this is just like a brief high level. Next is just like, how is everything kind of like packaged? I just wanted everybody to like see how everything is packaged. So what we have is we have a control plane that has etcd. Etcd is the primary database. So etcd is actually what stores all the information of like everything that is running like in your Kubernetes. So your pods, your deployments, right? Your stateful sets. So everything is kind of like the information is stored there. Okay, this pod is running on this node. So you can think of it like the database, right, layer for Kubernetes. And then we have the scheduler, like I mentioned. What the scheduler does is it decides where each pod goes on each node. So pretty much is you're gonna have like to request the pod, and the scheduler says, okay, based on like a whole lot of parameters, right? How can I decide where I want to kind of like run this pod? And then, like I said, we have like this is a multi-node cluster, right? We'll have 2 nodes, and then you have like node 1, node 2, where the kubelets actually runs on each node and interacts with the pod, right? So in terms of is it running? Is it dead? and then communicates back to like the communicates back via the Kube API server down to etcd. So there's one thing I just want to just note for everyone is that the Kube API server is like that gateway layer for like the control plane. So you can see here how it's literally just the one in front, right? Nobody actually talks to etcd, right? But the Kube API server is actually what is that layer in front. So anybody wants to create a pod, anybody wants to like submit information about like a pod, everything happens through this API server, and then it's finally stored in etcd. So that is pretty much all as regards that. The next thing I want to talk about is what is really at the core of Kubernetes. So Kubernetes this, but it's really a very simple concept, and it's called the reconciliation loop. Now, what's the reconciliation loop? It's just like I have a certain state that I have, and then I have an actual state that I have a desired state that I want to get to. And all Kubernetes just does is just do the work to actually get from my actual state to a desired state. So one example that I typically like to give is a thermostat, right? So a room, let's say, has a very cool temperature, and then you kind of like increase the temperature via the thermostat. And what that does is it checks the current temperature of the room, and then it checks your target temperature, and then does operations to actually reconcile that. And that's just really just what it is at the end of the day. It's not like it's just really just a whole events that actually get triggered, and that's just it. So what makes our version simple that we built? So across all of these layers, how do we simplify this logic? So for etcd is a distributed key value store. We're going to see about that like in the coming slides. But we use an in-memory state database, right, instead of like etcd. So it's an in-memory map where we store all the cluster states. There's no persistence, so it makes it easy for like everybody to kind of like run the project on their system. And there's also no distributed consensus. Another thing is for the API server, we just actually handled only one resource. So only pods and nodes are supported like with the API interface. So you can only register pods and nodes. You can't register anything more than that. For the scheduler, we implemented a simple round robin logic as opposed to like complex logics. And then kubelets just actually simulates actual running of the node, right? And then cleaning them up. So how the kubelet actually works is that it's kind of like works down a CRI interface. CRI is container runtime interface that allows it to have a plugin to interact with different container runtimes. Like currently, Kubernetes actually use Containerid as the default container runtime, but it allows it to interact with like these different runtimes, right? But what we just did was that we were able to kind of like simulate, okay, what are the different states, right? Just so that everybody's able to understand, okay, once I deploy my pod, this is just actually how it's actually getting it. And then kubectl, almost every Kubernetes developer's friend, every Kubernetes friend, right? And what it actually does is I implemented a simple CLI tool just so that we can have like that full experience, as you guys say. So quick side-by-side comparison of Kubernetes versus actual Kubernetes. So comparing for this talk, so I forked, yeah, just quick. Well, this is the actual Kubernetes repository. If anybody has never seen it, right? It's github.com Kubernetes/Kubernetes, and yeah, you can just like go through this. So I forked the repository and then went through like the codes and made like a couple of comments just explaining like how this relates to like what we did. But like this is kind of like too long to cover, so you could just like check this out. But we're just going to do like a brief summary in the interest of time of like simplifications that we did. So firstly, I said etcd is a distributed key value store. It holds all the cluster of data. So one thing that's important to note is that etcd is not actually part of the Kubernetes project. So if you actually go to the Kubernetes project, you're not going to see etcd like anywhere. So etcd is actually a separate project on its own. So this is etcd here, distributed reliable key value store. So it's just pretty much like how MongoDB is a separate database project, and then Kubernetes just decided that, okay, let's use etcd. And what you actually see is that you have things like client implementations where Kubernetes says, oh, we're going to wrap like wrappers around like etcd. So it's just like implementing like a MongoDB client, right? Typically. So one thing I want to just talk about is in terms of concurrency and locking. For concurrency and locking, we use the read-write mutex, right, to actually lock the in-memory maps, right? So this is kind of like similar where we allowed like multiple readers to acquire the lock, but once like a writer actually wants to actually write, right, then we block other readers from like reading that. And this is actually quite similar to like how Kubernetes actually performs concurrency and locking. It does this via optimistic concurrency. So there is, I've linked here a really, really interesting primer on optimistic concurrency. But what it just really is at the end of the day is that Kubernetes actually maintains what we call a resource version in etcd, and what it actually does is it allows multiple readers also to kind of like acquire the lock. But then at write time, what it says is that, okay, this reader acquired the lock. What was the state of like a pod? What was the version? And then when I want to write down to etcd, what I'm going to do is I'm going to just check, okay, has that red version changed? And then based on that, I can reconcile or like fill that, because like the state that you've read has actually kind of like changed. So we implemented that by just using like a simple music lock in Golang, right? And that was just how we kind of like simplified it. Next is pretty much the storage interface. So like I was saying earlier, what we actually did in our implementation is that we actually have interfaces, right? A store interface that has definitions for creating a pod, getting a pod, updating a pod, deleting a pod. But Kubernetes doesn't do that because it's wasteful and there's lots of like resources. It has to manage deployments, pods, replica sets, and all that. And how Kubernetes actually just does it is it just actually defines interfaces like get, right? And then remember I said that it implements a client on top of like etcd. So this allows it to be able to get anything entirely, like in terms that I can get a pod using the same API. So it really just makes it easy to work. Next thing is the API server. So pretty much for our API server, we have static definition for our API servers. So you can see /API/v1/pod, right? So this is using Gin in Golang, right? But then what actual Kubernetes does is that the routing is dynamic, right? So I mean, it can't necessarily like write all of this for like every form of resources, because there are actually a lot of resources that Kubernetes actually uses. And so the writing is dynamic, and it also supports health check, post-start hooks, and leader election, right? So leader election is pretty much how the API server kind of like decides, okay, who is actually that candidate that is actually controlling like the other workers. So I've actually dropped, won't be able to like go too deep on like leader election, but there is a really nice information on the Kubernetes blog on leaders on leader election. So it's just part of like the process in which Kubernetes actually manages like this distributed system. So that's like the main thing. Like Kubernetes actually is distributed, and then but our implementation is not distributed, right? Just so that you're able to kind of like run it simply without like the complexity on your local machine. And yeah, so down to the scheduler. So one thing that the scheduler does is they assign pods to nodes based on different policies, right? And what we did is we just do like a round robin implementation where I assign node to node 1. Next time you can go to node 2. There's no like there's no deterministic behavior as regards that. But the actual Kubernetes code, which is what we have here, is really complex, right? And has a lot of like scoring algorithms involved. There is this deep dive that I shared. So we can just give me a moment. So we can just basically, yeah. So we can just really just see some ideas as to how this actually works. So remember how I said that a pod is deployed on a node. Right now, there are questions is like, okay, if a pod has a certain memory and CPU requirements, right? Does the node that I'm deploying it onto, like, does he have enough, right? Is he able to like take that, right? Those are the things that he actually checks. There's also things called affinity, in sense that I can decide that I want my pod to be co-located, right, on, or a group of pods to be co-located on the same set of nodes, right? So this is particularly useful in like, let's say AI deployment, where I have like a couple of like instances as my nodes. Maybe I have like a G5, G4 instance, and then I have actually kind of like tweaked my application logic to kind of like work or maximize like the GPU utilization like on this node. And yeah, so affinity just helps me to be able to say, okay, yeah, I want this pod to actually just specifically run on this node and nothing else. And there's also the same thing. I don't want this pod to ever run on this node. So it's really, really interesting. And there's like a whole lot of scoring logic that actually gets involved. And one cool thing that I actually realized recently is that the scheduler scoring logic, you can actually, it has like a plugin interface that allows you to actually bring in like an external form of scoring logic. So if you're doing some really like low level stuff and you want to like perform like better scoring, right, you can kind of just like bring that in. So yeah, bringing it all together, we have roughly around 10 minutes. That's nice. So bringing it all together, end-to-end life cycle. So what happens when you actually create a pod in K8 Lite Go? So like I said, in K8 Lite Go, we actually just use pods just to make it easy for everybody to understand. So the API server stores it as pending, the scheduler assigns it to a node, and the pod transitions it to scheduled. The kubelet picks up the pod and it transitions it to running. and then yeah, deleting the pod marks it as terminating, and Kubelet cleans up the pod. So that's just pretty much what we have. So I actually had prepared a demo for this, but I mean, I think we have like some minutes actually on the clock, so we can actually do like a live demo, right, on this. So yeah, this just demo just shows. So let's just actually like do like a live demo. So the demo is just really just going to like run the program, like run create slice go and just like see how everything actually works in action. So just like I said, this is the public project for it. There is README that kind of like explains everything. So it's predominantly written in Go as a homage to the fact that Kubernetes is actually written in Go. So that's just pretty much everything as regards to it. So let's just get started. So this is our cluster, right? And then the first thing I do is, let me just open the README. So like I mentioned, there is an API scheduler, API server scheduler, and then also like the kubelet. And then we also have like our memory interface. So you can see that here, this is our API server code. So this uses Gin, your basic off the top, like say web server interface. So what we just do is we're able to kind of like define, so say the post request, and then this handles that, and there's a get request, and this is for like the pods. So this is grouped under like the namespace pods, which is actually how Kubernetes actually like stores things. So if you actually go to, I think it's this here, yeah, which is actually how it's actually kind of like stored in Kubernetes. So it's really just like those things that we kind of like did to just like make it similar. Yeah, so you create the pods and all that. So the next thing that we have is this kubectl Lite, your basic CLI interface, right? I mean, we're not building a CLI, so we won't really like go into this. And then this is your kubelet, which actually has the implementation of the round robin. So what it just does is it gets the list of pods, right? And then it goes through each pods, and then it kind of like checks, okay, is this pods deleted? The next thing it checks is that, is it actually scheduled? And then based on if it's scheduled, what it actually does is that it actually finds a node that it actually wants to like run the pod on. And if it's actually running, we actually don't like run the pod because we don't touch the pod because it's actually already running. So let's just actually build this out. So if I go to the README, I have a make file that just really makes it easy for us to kind of like run all the commands. So I'm just gonna do a make build. So what a make build is gonna build all the Go binary files that we have. So you can see that we're building the API server, we're building the API the scheduler. So everything is up. So the first thing that you want to run is the API server, right? Because that's actually like the interface that everybody talks to. And like I said, in the API server, what we have is we have our store interface, but what happens is that this is in memory, right? And this is the read-write mutex that I was actually talking about earlier. And so the API server just talks to this, right, internally. And so let me just run make API server. So yeah, I always mix this. This is make run API server. Yeah, just give me a moment. Yep. So this is make run API server. So we have our API server is running, and yeah, so this is just like your basic runtop rep server is running. It has a database at the background. And then the next thing we could run is the scheduler, because like I said, the scheduler is pulling the API server and saying, okay, what pods is available for me to actually run. So let's run the scheduler. And then you see that saying no pods to schedule, starting schedule loop with an interval of like 5 minutes, 5 seconds rather. This is something that you can change. So if we look at the API server, we can see that the scheduler is pulling the API server. What pods is available? What pods is available? Like, and that's just really just what it does. And then we'll come down to the heart of like Kubernetes, which is actually running our nodes. Remember that our kubelet actually runs on our nodes. So we simulate that by just like running the kubelet binary itself. And what that's going to go is that it's going to create like different nodes. So I'm just create a node called node 1 with this node address. So you can see how, just create a node called node 1 with this node address, and then local host. This doesn't really tie into anything because like there's no networking, but it's just to give us the idea of like how it actually works in Kubernetes. So I run this node. So it says kubelets for node 1 registered start pod sync loop, right? With interval of like 10 seconds. So this is actually running. And then let's just go to this. I'm going to run the second node here. So we're just gonna, so this node is actually running. Then now we come to like the midst of it. So what we can do is we can actually get pods that are currently running in our system. So I'm going to do make kubectl command. So this actually looks like how we actually write kubectl code. I mean, kubectl, if you're actual Kubernetes cluster, you're going to do kubectl get pods, right? And this is actually very similar, right? So it just gives you the idea that this is actually like how Kubernetes actually works. So get pods. So this is null, right? Because there's no pods. So if I try to do get nodes, you can see that the node one is actually ready, and then so the node one is actually ready, and the node two is ready. So let's just create a pod. So what we're just going to do is we're going to create a pod. So let's create two pods just so that we have like 5 minutes left. Let's create two pods and just see like how the life cycle goes. I'm going to create this pod and I'm going to create this second pod. So just like I said, what happens is we have these two different pods. Now let's look at, so we see the request registered, right? This put has changed this state from like not available, but like it's actually now pending, right? So if we actually look at the nodes, so these are our nodes. So this is our node one. Sorry, this is the scheduler. So the scheduler finds one pending pod, finds two ready nodes, and schedules the pod down to one node, and finds another another pending pod, and schedules this to another node. So we see that so one pod gets scheduled to node one, and the second pod gets scheduled to node two, which is really nice, right? Now we can see that this is our node one, and you can see that it finds the scheduled pods and starts it, and it says pod with this is currently running. And we see this next one, it says this is the second node, pod with this is currently running, right? So that means that we deployed the two pods and they went down to like the separate nodes. So if we actually run the get pods, we're going to see that we have pod one that's running, it's running on node one, and pod two is actually running on node two. This is actually just based on like the algorithm that we had. That's the round robin algorithm. But if it was actual Kubernetes, there's a lot of things that will go into like how this is actually kind of like decided, like, okay, how many resources do I, or what resources do I have on this node? And is it able to kind of like take it? So that is pretty much everything as regards that. There's also a video here if you want to watch. So what's next for this project, right? So like I published the article on the project, and there was like quite like a great reception from like everyone. So I think like yeah, what's next is really going deeper into like all of these different components. So enhanced API server, how can we kind of like implement something like more realistic watch support? Advanced scheduler, like scheduling is something that I'm really passionate about in Kubernetes generally, and because like scheduling really changes a whole lot, especially when you're working with like AI workloads where scheduling is not just about like requests, but like you want to kind of like schedule based on like tokens, right? So what requests have more tokens, and also like there are really some advanced things that we can kind of just like look into. Then a full-featured Kubelet, right, with like CRI integration, and then also like the controller manager and building more implementation of like more complex resources, because we only did pods, but we could do deployments, replica sets, stateful sets, and yeah, networking is another like beast in Kubernetes. And yeah, so just that. So I think like in the coming months, I just hope to like publish like detailed articles are like about like different steps of like this. I think if there's anyone specifically that we think that would be beneficial to like going in, then we could kind of just like suggest that, and then yeah, so just publish different articles and then going deep. And yeah, it's actually open to contributions. I would try to work out a way in which I could kind of like have like requirements, like if this is actually the implementation that I see, a simple implementation for like the API server that we could improve, and then on the repo we can kind of just like discuss, and then yeah, we could kind of just like assign, right, just to get everybody like integrated in terms of like building this out. So yeah, that's pretty much that. Thank you everyone for this talk. I hope you learned one or two or more about Kubernetes. Infinity on Twitter, _Infinity on Twitter, me Festus on LinkedIn, email people back up on Instagram. That's actually an inside Kubernetes joke, right? So it's like what gets thrown when the kubelet has for some reason can't like pull the image right onto the node. Yeah, so that's pretty much it. So now, like we did it before we started, and yeah, so we did this earlier before we started. So let's just do it now. So how confident are you about Kubernetes now? Just to have some form of like feedback. How confident are you about yeah, implementing this? So let's just see. I mean, based on like the last 30 minutes I said, right, did this help, right? All right, so it's time for questions. is there any plan to make this like Minikube? Yeah, like I think that's the entire goal. But if there's one thing I want to just clarify is that I want to keep it as educational and light as possible, and not necessarily like replace or like build like maybe entirely production ready, because like once you have like those details of production ready, that's when like it really gets complex, and then a whole lot of people just so feels hard to like it feels hard for people to contribute. So what I actually want is I want an abstraction where people can kind of like learn things in like in steps. Just like now we've abstracted everything down to like simple interfaces. We could build it on top of that, right? So maybe extend one part, build deeper implementations right on that. But still it's not necessarily meant to be like a production replacement or a even sub production replacement of Kubernetes. It's mainly just to help everybody right understand how Kubernetes is actually written, and if we're able to kind of like write little abstractions based on how Kubernetes is, and we're able to kind of like view that. Obviously, I mean, if we're able to get something that that can actually like run a cluster, but it's still in a certain way that people still understand what works, then yeah, that's a good place to be. So it's really nice. I can see that people can explain to others. I'm going to rebuild my own Kubernetes from scratch. Yeah, that's right. You should rebuild lots of things from scratch. I can finally pronounce kubectl or is it kubecontrol. That's nice. I can deploy something might not scale, but glad that at least nobody is lost. And yeah, so that was just pretty much just that. We have like 3 minutes left. Is there any other questions? All right, I see Hilary on the chat says he has questions. You could just post that in Q&A. Yeah, and like I said, I mean, if you can reach out to me on LinkedIn, you can reach out to me on Twitter, and yeah, I'll be happy to like answer any questions, right? And yeah, I think like there've been a couple of like forks of the project, so I think that yeah, feel free to kind of like suggest, right? Feel free to kind of like suggest, feel free to suggest like anything. Like the whole goal is just to be like if possible, right? We can kind of like as a community or just really just like go from an education point of view to kind of like implement Kubernetes from scratch, like keeping it on abstractions. Yeah. Okay, so we have 2 minutes left. So I will just keep this up in case anybody wants to share. So I mean, we're seeing a lot of I'm going to rebuild Kubernetes from scratch, and that's nice. At least I'm happy that this talks has been able to inspire everyone to build that from scratch. Yeah. Yes, and like I think this slide is definitely going to go out. So feel free to like go deeper into like some of the resources that I mentioned. Yeah, I think I forgot to mention this, but like SCD uses a rough consensus algorithm, right? But that was like beyond the scope of this talk. So feel free to kind of like also dive deep into like this too. But like yeah, in the coming months, once we kind of like go deeper in like some of all these things, yeah, we'll be to kind of like find out what works. I think one question is just like I'm not so sure like what I'm not sure like what. Okay, there's a question from do you have your own RAF store? So this was an in-memory store, so not a RAF store. So if you check this, and also if you also check the code base, let me get there. Yeah. So this was just like an in-memory, right? But then used like the read wide mutex in Golang. So yeah, it wasn't there wasn't like a RAF store that was implemented because of like the distributed nature of like the like the Raft algorithms and to implement that. So yeah, that's I think that is all. Yeah, that's all. Thank you very much for coming to the talk. Yeah, thank you very much for coming to the talk. You can find me online using these resources. And thanks once again to the people that organized, that's the organizers of the SysConf conference. It was really nice to speak. I enjoyed the experience, and yeah, see you next time.